Hello and welcome to another What's New series of webcasts presented by Digital Dimensions. My name is Enrique Garcia and we'll be talking today about what's new in simulation, motion, and flow simulation for 2012. So here's the summary of what we're going to be talking about today. Basically, we're going to be breaking up our presentation into three segments. First, we'll be talking about simulation improvements. Second, we're actually going to be incorporating the motion and optimization improvements into simulation since everything kind of melds together. And lastly, we'll go ahead and cover our flow simulation improvements. Let's begin to talk about simulation. So 2012 improvements I'd like to comment on has been fairly light compared to other releases. One of the big emphases for 2012 has been the incorporation of beams into dynamic studies. Let me go ahead and show you an example of this. So in previous releases, we were not able to perform a dynamic study with beam analysis. We had to do solid elements. 2012 has made this a possibility. So if I go in here, you'll notice that we now have the ability, if we dig deep enough, to work with a dynamic study and also incorporate beam elements. Some other enhancements towards working with beams is the ability to go in and respect the cross sections of your beam elements. For example, here you'll notice at the bottom we have a plate, and if I go in and I show you the mesh for this particular model, you'll notice that we now respect the other geometries and the cross-sectional areas so that we have a more accurate result when we interrogate our model. If I go in and hide my solid body, you'll notice that we have a mesh that more accurately reflects the top surface of my design. For example, let me go in and hide my solid body here. You'll notice that we have the geometry is reflected onto the surface there of our shell element. So those of you who will be trying to do this for the first time and you're using beam elements and you're using solids or shells, you want to make sure that you update your joint groups before you go in and you mesh your model so that you can ensure that you have a joint that's interfacing between a shell element or a solid and the beam element. In this case, I've calculated my joint groups. I clicked OK. I'll recalculate my joint groups there. Then when I remesh the model, we can ensure that we are using the neighboring face of the solid model or shell model as it touches the beam element. So now we have a pretty good mesh. Let me go in and run our study once again, and let's talk about results using beams in 2012. So beam mesh and result plots can now be shown on actual beam geometry. This can also be shown with e-drawings as well. This is the very first release where we're able to show what the actual cross-sectional areas look like when we're interrogating our results. If I zoom out of here, you'll notice we no longer have the characteristic looking cylindrical or rods that represent beams. We now have a more accurate cross-sectional area of what the original geometry looks like. If you prefer to go back to your original rod geometry instead, it's very simple to do. You just go in and you edit the definition of each plot and you toggle off this render beam profile option. You'll go back to the original type of display that we were used to in 2011 and prior. This also works for all of the other types of plots you see here. All we do again is under the advanced options, we toggle on the render beam profile option and show the plot. Okay, next I want to talk about motion, and actually more specifically the parameters interface has changed quite significantly in 2012. Let me open up an example to show. So to get to the parameters box, we'll go to the insert menu, we'll go down to, it's going to be under the design study category, we'll select parameters. Now this automatically opens up your dimensions so that they're easily selectable. You'll notice here to my top left that the parameters window is significantly different to prior releases. The old window, it was harkened back to the old design, the simulation design scenarios. It was a different interface. With 2012, they've finished making the leap forward and making all of our tools a little more synergistic, easier to play nice between the different modules of simulation. For example, here I can choose maybe this diameter dimension. Again, I select the dimension, I go in and I type in the variable name here. Maybe we'll call it diameter A. Hit enter. I have another row which I can select another variable I can change. Maybe I want this height here. I can enter another descriptive variable, etc. Now I have these different parameters in which I can use for my design studies. So how do these parameters come into play with motion studies? I'll tell you here in a couple of minutes. Before, I want to finish this last thought. So now that I have these different parameters in that window, these are variables that I can change. The next step would be to go in and create a design study. Now in my variable section, I can go and choose those diameters. The diameter A, which I've determined there, I can give it a range. My second variable will be my height, and then I can go ahead and optimize this to the design that I want with proper constraints and goals. So that is the new parameters interface in 2012. So when it comes to motion studies, you can now create a simulation design study that will optimize motion studies or the features, motion study features. Let me open up an example of that here. So currently I have a motion study here under my animation tab. Very, very simple study. All I've done here was create a rotary motor around my crankshaft, and I have some result plots here. Now the way we link these motion studies to a optimization study or design study is when we go in and we create one of these result plots. For example, here I have, I'm wanting to know the angular velocity and the magnitude of the angular velocity of my motion study. At the bottom, I have a little checkbox under the plot results that says create new motion data sensor. When I click that option, SOLIDWORKS will create a new sensor inside of my design tree. And notice I have two here. One's the previous one that I've created. Now we can take this sensor information and I can create a new design study, which I've done over on this side. And I can take and I can apply these velocity sensors and I can pay attention to them as feedbacks. These sensors as my constraints from the motion study coupled with my variables from the new parameters window we have available will allow us to go ahead and optimize our motion studies for 2012. So that sums up what is new in motion studies and optimizations for simulation 2012. Again, a very light release when it comes to simulation this year. Next, I want to talk about flow simulation. For flow simulation, I want to break down the what's new features into three separate categories. One, we will be talking about the technology and physical models. Second, we're going to be talking about preprocessor aspects that are new in 2012. And lastly, we'll be talking about post-processor aspects that are new in 2012. The very first enhancement I want to speak of is an improvement to the scalability of flow simulation. So as the software is continuously improved, the flow simulation becomes more easy to expand and contract its resource pool to accommodate heavier or lighter loads for computing. So here over to my left, you can see a graphic that shows the scalability ratio in 2012 versus 2011. So again, I'm looking forward to noticing these changes in the next coming release. Another area of improvement has been the mesh or the mesher inside of flow simulation. In previous releases, we had partial cells that were simplified by our geometry by slicing off sharp edges or corners such that we interpolated between one face to the other, causing our models to be a little less exact. In order to combat this, we had to increase the mesh density and the number of cells per X, Y, and Z in order to accommodate for this interpolation. This new technology for 2012 uses additional information from the actual CAD data or 3D CAD data to construct these to construct a non-simplified geometry so that we can respect all edges without having to increase the mesher intensity or decrease the mesh size of our models. Another very nice aspect to an improvement with flow simulation is that now we can analyze shell models created in SOLIDWORKS inside of flow simulation. In addition to that, we can export these results and apply them to a shell element inside of a FEA analysis. The performance boost for this is huge. We no longer have to worry about creating fully contained models. We can now represent models with simple shell elements, get the CAD data out quickly so that we can analyze the design efficiently. Let me show you an example. So again, how many of you guys have gotten a fully detailed CAD model that you want to insert into flow simulation, and you end up figuring out that you need to highly simplify the model, make sure all of your setup assumptions are sound, all of your goals are converging? Well, now you can start off simple, so you can start off maybe creating a surface model of everything and run a flow simulation study. You'll notice here I have a flow simulation study already pre-done. Nothing out of the ordinary to set up a flow simulation study with shell elements. The software just knows to respect the geometry. You'll notice here in my computational domain, we have an external flow analysis here with some global boundary conditions. Let me open up some results just to show you what we have here. We have a surface plot, so we have some data here. And let me show you some flow trajectories. So again, nothing out of the ordinary. We're taking regular old shell geometries created in SOLIDWORKS. We've created an external flow study, and let me close this out. Next, we're going to go in and export the results. To do that, very simple. Go to the flow flyout, go down to Tools, choose Export Results to Simulation. Once that step is done, now we simply go over to our FEA package. We create a new study. I've gone in and created one for us. But let me show you with a brand new study. I'm going to go in and create a new simulation study. Again, very simple to do. I'm going to type in import flow results. I can go in and choose in my, just do a quick setup here. The main thing here is to go into the external loads, choose flow effects, and go into the fluid pressure option and bring in your FLD model. Point to your results, your flow results for 2012. Click OK. This will bring this in automatically. Next, I'm going to go in and bring in some of my fixtures that I had from my previous study, and perhaps my mesh. Now let me run my study, Again, we've successfully brought in results from a CAD, a shell model from CAD into Flow simulation, exported from Flow, imported into our FE results. I hope this will save us all a little bit more time when we're creating our models. Lastly, let's go back to our simulation study. Let's talk about some of the new enhancements related to post-processor activities with flow simulation. The first thing I want to point out, if you look here at my plot, my surface plot, is the ability to go in and customize the little legend. I can actually grab a hold of the whole thing and I can move it around, which is nothing new. This is what's actually new, is I can grow and shrink the actual size of my legend just to fit nicely with maybe different screen resolutions for screenshots or export data out. The next enhancement that I want to just touch on is the ability to go in and change the number of levels in your legend. Again, if you want to make your models more discrete or more continuous in the visual aspect of your plot, you can actually go in and on the fly change up the number of levels. Previously, you had to go into your color bar options and change that in the property manager. So that's something that can be done on the fly in 2012. One more thing I failed to point out was the ability to auto-scale your legend. Again, when it comes to showing results, communicating with other engineers and colleagues, you always want to be able to show a highly dynamic range in colors so that you can accurately convey the results to your colleagues. So you can click on the actual legend and change your colors in this case, so you can make sure that you hit the lowest magnitude and the highest magnitude and give your models a very good palette of color change in between all these different magnitudes. Other improvements for post-processing are going to be in the area of flow trajectories. Let me go and show this external flow trajectory here. So let's assume that this is a larger model, and we're only interested in perhaps the top portion of the model, this ball portion of the model. This other data perhaps we're not interested in at this time. Well, I can go in and crop my flow trajectory by editing the definition, or also upon the initial creation of this in the property manager. At the very bottom, we have a new section called crop region. Again, let's assume that we want to pay attention only to this top portion here. I'm going to go in and visit my crop regions category, and let's go in and take a look at the Y length and volume. Let's switch that up to maybe 2 inches here. You'll notice there that this will reduce the size of my volume. When I click OK, it's going to refresh my flow trajectories, so I can only show that portion of my data. Again, this can be done many different times with all of your different degrees of freedom, all X, Y, and Z. Okay, the last enhancement that I want to cover is actually going to be a preprocessor enhancement. Let me zoom into that graphic here. So in 2012, for our contact resistances, if I wanted to go in and specify a particular region that perhaps is touching a solid to solid contact, and maybe had some geometry like you see over on the left-hand side, or these prongs that bleed over the edge. Previously, you had to go in and use the split line tool to segregate certain surfaces so that you're only selecting surfaces that touch other surfaces. Now in 2012, and in flow simulation 2012, you no longer have to go in and create the split line. You can actually choose the two touching surfaces, and when you click on this little checkbox for apply to solid only, it will ensure that you're only applying this condition to those touching surfaces. Let me show you where this option is located in flow simulation. For example, in this model here, we have this simplified electronic enclosure model, if I want to apply this contact resistance, I'll go into Flow Simulation, Insert, Contact Resistance. I'm going to go and choose my two selections, the top surface of the enclosure and the bottom of this geometry. Now, if I want to apply this contact resistance, again, I choose my type and the thermal resistance of whatever I want. This is the option of key here. I want to choose Apply to Solid, Solid Only. This will ensure that I'm only applying this condition to my two coinciding and touching faces there. So this little triangular sliver of interest would be what we will be applying the contact resistance to. So that's the last enhancement that I have to show you for this morning. Again, the emphasis for enhancements with 2012 was not to overflow us with all types of bells and whistles. Again, subtle differences that will make a difference in the way we approach our workflows and hopefully address an increase in efficiency in how we set up our studies as far as shell elements. And they seem to go back to the and work on the back end of the product as far as fishing, as far as working on scalability and improvements to the mesher. Okay, well, I'll go ahead and end our webcast this morning. Again, thank you for joining us and spending some time to talk about the What's New series of webcasts. In case you missed the beginning portion of our webcast, we typically archive all our webcasts a couple of days after they air online. Please visit our website for this webcast and any additional webcasts at www.ddicad.com. Thank you very much.